Okay, now we're recording, and let me present my screen. All right, you guys got this now?
Yeah.
So what we have here is the brew circuit, and it's a circuit that works but is very poorly designed. And so let's see, what is the equation for this circuit? Can you guys see it well enough to try to figure it out? I'll give you, well, you can even pause the recording and it'll give you a few minutes to try to figure it out. Or do we want to walk through it together? And I can't see your faces now because I'm up at the smartboard.
Let's run through this one together. It's been a while.
You want to walk through this together? Okay. All right, so temperature and pressure going into an AND gate. So what's that?
TP.
That's TP. And then that's going into an OR gate with water.
TP plus W.
TP or W. And then let's see, I have pressure going to an inverter. So what comes out of there?
Pressure naught.
P naught. So then I have what? TP or W ANDed with P naught. So what do we got?
TP W P naught.
Well, it would be TP or W ANDed with P naught. Okay, and then I guess the next gate, that whole thing is ORed with what? That's
Temperature.
ORed with temperature or T. And then what do I have down here? I have an AND gate. That's what?
TP naught.
TP naught. So then that is ORed with this whole thing here. So I guess my final output would be what? I've got TP naught or TP or W. I'm writing too big. Let's get a smaller marker. Oh, or I could do this. No, maybe. No, can't get it. Okay, let's get a smaller marker. So my final brew equation. Oh, my final brew equation. Now that's what it should be. But from this crazy circuit, what would I have? Let's just come down here. I'd have TP or W and P naughts or T or TP naught. Okay, so what do we need to do with that? Now we got to simplify that. So hopefully at this point you're getting a little more comfortable with Boolean algebra. On that first term, looks like I probably could just, distribute that. So if I distribute, I would have T, P, P naught, or W, P naught. on this second thing here, this really isn't that hard to simplify even. What can I do with both of those terms? What do I have in both of them?
A T.
A T, so I can factor out a T. T and 1 is T, and T and P naught would be TP naught. And then what simplifies? T, P, P naught. What's that? What's P, P naught?
0.
T, P naught is 0. Or I have W, P naught. Or T, and what is 1 or P naught?
One.
Oring with 1 is 1. So T and 0 is 0. Or WP naught or T. The ending with 1 is whatever that variable is. So of course, oring with 0 gives us a much simplified proof circuit. You ever seen those old vending machines that distributed coffee or hot chocolate? You know, they created those in the 70s. You know, with the advent of these TTL chips, and they really could control, you know, the whole brewing process with old technology. Sometimes you still see them now. I would say now most of those machines like this are a little more complicated. You can input a credit card. Sometimes they still have the old styles. Every once in a while, you can still see one that's up and running in a like hospital waiting room or something like that. Let's see. All right, so now what do we need? We need P naught W or T. Doesn't matter the order on that. So can we draw that circuit? That's pretty easy, isn't it? PWT and P needs to be inverted. And that needs to be ended with W. And forward with T. So really, that's pretty simple. So what do we have up here? I think what we want to start looking at then is the conclusion questions. You know, how do you know, what process do you use to simplify logic using Boolean algebra? I mean, it's really hard to explain, but how would you describe it? What do you do if you're given a crazy equation and you want to simplify it?
You look for like terms that you can factor out.
Yeah, you look, I mean, that's the simplest thing. There's a lot of factoring, ending with zeros. You look for like terms that can factor, you distribute. How do you know when you've arrived at the simplest equation? Sometimes that's hard to see. Now, when you can't do any more steps, although that question number 6 was pretty tough to see at that point. Actually, my numbers got out of order. This would be question 2. This would be question 3. But sometimes that's hard to see, and you don't necessarily always know if you're at that simplest expression. Sometimes it is hard to tell. Question 3. This one everybody should know. Other than doing Boolean algebra, how do you prove two circuits are equivalent? What do they have?
The same truth table.
That's right, the same truth table. Okay, and question number 4. This is the important thing, and one of the reasons we do Boolean algebra, not just to simplify it so it's easier to breadboard and prototype, but it's a cost savings. So what do they say here? They're saying each gate costs 15%, and the company was going to make 5,000 or 500,000 vending machines. Okay, so each gate, how much was each gate? 15 cents. So if we go back a page, how many gates do we have? 1, 2, 3, 4, 5, 6, 7. Okay, and in the improved simplified circuit, I've got 1, 2, 3 gates. Okay, so how much does our new design save? Well, 7 times 15 cents times $500,000 minus 3 times 15 cents times $500,000. How much money did you save?
A lot.
Everybody have their calculator handy?
$300,000.
Is that right? Yeah, I think so.
Yeah, he's
Yeah, I
right.
got 300,000 as well.
Yeah, so having something efficient over the long term is a huge savings. And then something also in economics that's referred to that they bring in here is the return on investment, ROI, the rate of return or rate on investment. So what's the savings? The savings is $300,000. And if it took you 2 hours to do that, that's $150, including your coffee break. Whoops, not 1,500, but 150. And that didn't even take us 2 hours to do. Although you might have to redraw the circuit and make up the schematic and something like that. So in terms of whatever, there would be a few additional steps in making sure this is ready to go to production. So what's your return on investment times 100%? What's that, 2 million? 2 million percent, is that what you got? That's what I got. Is that right?
Yeah, 2 million%.
You get 2 million% return on investment, which is a huge return. So that can save people a lot of money. So that's part of where this is headed. Anybody want a bonus question? Ryan does. Right, Ryan?
Ryan
Let's
would
see,
love
if you
one.
remember back to, what is it, 1.3, we had 2 equations. What do we have? A naught C or AC naught or A B naught C. Anybody have their notebook to double check that that was one of the equations? I'm pretty sure it is.
Yeah, that's the one.
Yeah.
And the other one was, what's the second equation? The product of sums, if you have it. It's A or, is it A or B or C, or are those knots?
A or C, and then I think that's and A naught, B naught,
Yeah.
C naught.
Okay, now we know from doing that section that those two equations have the same truth table. So there's your bonus question. In fact, if you can solve that question, I won't even, you get an A on the next quiz. That's an extended response quiz question that you can do ahead of time if you want to. You got to prove by Boolean algebra that those two are equal to each other, not by truth table, but by Boolean algebra. So you can have one question instead of a whole bunch of questions for your next quiz, and I'm even giving you it ahead of time. Anybody want to do that? Any takers?
I'll give it a shot.
So it's, I will tell you, you got to do some things like we had to do with question number 6, where you have to make it more complicated before you make it simpler. And I would start with the product of sums. So actually, I would start with A or C and that with A naught or B naught or C naught. I would start with the right side of that equation and try to turn that into the left side. It's a little bit easier going that direction. Okay? So, hey, that's all we got for today, guys. So I'm going to go ahead and stop